Engine. And this is the first meeting from our monthly series. So we're going to have this meeting every month. I think it's the last Tuesday of each month. And for this meeting, Michał is gonna do like an introduction to the new execution engine on a very high level. We will also have some, Q&A section for your questions. And then Michał will just provide like the recent updates, and going forwards for the next meetings, we will rather just do the, what has been changed and what has been added to the new execution engine. With that being said, I think I'm gonna give the mic back to Michał. Yeah, the floor is yours.
Okay, so um, so for some time now, I'm working on a new virtual machine for Casper network. Because there's many problems. There were many problems with the current one, the one in 1.5x release, that are not sustainable for the development of the platform. So I will maybe start with the issues we currently face with current execution engine. So for instance, URefs are the main issue that are basically the main issue with UREF is that once you grant UREF, it's just forever and it stays in the storage and occupies the space, right? You can't revoke it. So that's another issue, right? So once granted, it's forever. We tried since the beginning. We tried to motivate people to use them less, but it's just there, right? You have to support it. And in the new VM, I'm working on the URefs are gone. Like you don't need to worry about it. It's not surfaced to the user. So it makes. I think it mostly it is contributing to the improvement, like better URefs, and doesn't scare people that much now with at least in the new model. And that as a consequence, purses are also gone because purse is just specialized UREF. So instead of UREFs, there will be support for Payable. I mean, Payable. Yeah, I think it's de facto standard. Let's say it's Payable functions. So you execute the code, but before executing in one transaction, you can pass tokens to the contract, and the contract will act upon the value received. So it will make the accounting easier. For example, in let's say in the example of a wrapped token, you don't need to do complicated things to pass UREFs around. I can just pass the value and then associate that value with an account, and that makes it easier. And there's also some technical issues with the current execution engine. For example, there's many host functions. It's a bit more technical, like low level, but it's also makes it complicated for us. So over time, we grow like almost 60 host functions, and it's mainly duplicates that there are functions that does mostly the same thing, but they are named differently. And some interactions with the host wasn't host interactions require multiple interactions with the host that is also contributing to expenses because each host function call is charged, right? You are charged for it, but there's also additional overhead of the WASM opcodes to deal with. So if we can simplify the interactions, then it will also contribute to smaller overhead of WASM, so less opcodes to pay for. And consistencies, like sometimes we serialize data in some way to pass to the host, sometimes not. It's not consistent. And all in all, the WASM virtual machine is also not the greatest in terms of speed. It has constant pros and cons, right? So in terms of kind of VM, it is interpreter, which is slow. And like to be fair to the interpreter we are using, back then when we started this project, there weren't many options for Rust ecosystem, and we chose the interpreter because it was readily available and stable. But over time, the ecosystem of WASM and Rust just grow, and there's much more, much better options for blockchain, especially. So that's also will be changing in the new VM. We will use Ahead-of-Time Compiler to run basically WASM as native code, and that's another consequence of changing the interpreter from interpreter to Ahead-of-Time Compiler is that it will be faster, and faster VM means sure opcodes, right? Because you can basically execute more opcodes in the same time, right? And that will contribute to just more, lower expenses. Or faster execution depends. It's like at least two-dimensional graph where it's speed and amount of execution, so we can like think about it and find best trade-off.
I can
And
s- Sorry, Michał, I can see somebody raised a hand. So if
oh,
you
sure,
want to,
yeah.
if you want to ask about something, please put your questions into the Q&A. So in the top, in the bottom right corner, you will see this icon with triangle, rectangle, and circle. When you click on that, you will see the Q&A, and here's where you can post your questions. We're gonna answer all of those in the Q&A section of this presentation. Thanks, and sorry for interrupting.
Right. Yeah. So this is a big this is the biggest change, I think, the engine and the interfaces as well. I would say also big. And I will try to explain in this short time some of the benefits of new interface, new engine. And how about new slide, Adrian? Okay, we talk about this. Oh, yeah. Yeah, I have my notes on my screen, but there is much more information. Yeah, so let's talk about the goals of the new VM. So I talk about like faster VM and some better thought design in terms of like host WAS interactions, but it's all about developers, right? So I really want to focus on high-level code that is easy to understand, idiomatic Rust that shouldn't have too much friction. So the idea is to once you know Rust, you should be able to be productive to develop smart contracts on Casper network. So the focus is on the high-level code with macros, but at the same time, those macros wouldn't go into your way. It should help you and not like have too much magic right in it. But still, the low-level interface will be easy to understand. And you should be able still to like if you find some limitation, you should be still able to use some lower level routines to achieve something. I was talking about the Payable stuff, but there is also schemas. That is very important for discoverability. So schemas is basically a description of the smart contract. So it will list all the types with the serialization schema. The serialization of all the types, and it will list all the entry points in the contract with all the arguments with all the types. So given schema of given contract, you will be able to interact with in the contract. So you will know how to construct a type, how you will serialize the type, what kind of arguments you need. So that should be complete description of the contract. So the clients will be able to consume it, for example, right? Like, let's say JavaScript client can consume it at runtime, generate functions to call into contract. Let's say Rust consumer could generate Rust code, right, based on the schema to have like statically compiling statically typed client to a contract. So that is very important. In my opinion, it's all contributing to productiveness. I would say, which something, especially schemas, is missing. Right, we only have informative, like just purely information on the. If you check the Casper Live, some contracts, it's just purely informational. There is not much enforcement from the host for what the contract is describing, and that is leading to a situation where we have to like special case some contracts. And yeah, I think the new model will be much more. At least the new model should improve on that. And how about contract upgrades? Yeah, this is my opinion. Don't quote me on that, but in my opinion, currently as implemented in current engine, the contracts are, yeah, technically we call them, they are upgradable, right? But what is really happening is that once you add new version of the contract, we give you new contract hash, right? So we do have contract package hash and contract hashes, and that is, I think, I guess some community members are fine with that. They are used to this, but some people or people coming from other chains, other networks, I think they are still confused by that. So once you add new version of the contract, we give you new contract hash, and that is totally new entity. You can only match it based on the contract package hash, which is sometimes confusing. So if yeah. And in the new model, the contract hash will be the yeah. I think it will be even more confusing. But let's just say in the new VM, if you install a contract, it will be only one identifier that has meaning, which will be the smart contract hash. Let's say that is the only one identifier for a given contract. And the upgrade procedure is also different. Is that you will be able to supply WASM bytecodes at runtime, and then not only you'll be able to upgrade the code at runtime, right? Sorry, at given upgrade, but you can also install new contract from WASM, right? So that also leads to new better implementation of factory patterns, right? Where you, let's say, keep the WASM or you supply the WASM from outside off chain to on chain by argument, and that also I think improves on the factory pattern from 1x. So in terms of the upgrade itself, the procedure of upgrading the contract, it is also simplified, where where new VM, your smart basically, basically your smart contract, you will have entry point, and you will just invoke, let's say, Casper upgrade function. So the contract is deciding on itself that the upgrade can occur, and that also gives interesting side effects of that, where the contract will decide who is able to invoke the upgrade procedure, who, like, access levels you can implement, like customized checks before performing upgrade. So like you will not be limited by the 1x behavior, where we have like groups, access level, access what was that, group access control and stuff like that. It's all about like flexibility in new VM. There will be I will try to show some examples later in the code. And testing is something that, in my opinion, in by default, in 1x, the barrier to entry to write tests is quite high, I would say. So in the new model, in new VM, you'll be able to like just drop like CFG test and hash test and function, just like test your logic if you want. So you don't need to compile it into WAS and just test your function correctness, right? So it will be easier to just write tests on that. And of course, running WAS is also supported, right? It's just that I will try to lower the barrier to entry to write tests as much as possible. And yeah, I guess next slide, please. Oh yeah, so yeah. So let's look at this code, right? So it's very low level. It's current 1x API. It's very verbose. And low level, there's no Mongo. Like, what does it even mean? Externcy, do I even need that? What's the meaning of that, right? It's just the boilerplate code that I have to remember about, but I might not fully understand the meaning of it, right? Like storage also, like get key. Yeah, it was fine for its purpose, right? Like the model was procedural, structural. So yeah, but it also added friction, in my opinion. There were a couple of examples in the community in the contracts developed that even at one time even some of the auditors got confused by let's say returning URefs or something like this. So yeah, the idea was good, but like in practice, it also added some confusion to some people, right? And just setting up the code, setting up the contract, like on the second picture, you have to define all the entry points yourself, right? So yeah. So new VM, we focus on like high level code. Like let's go to the next slide. Right. So this is a very simple example of the new VM smart contract. There is a contract state where all the it is serialized into one object in the global state. So you don't need named keys for storing data. It will be just your state of the contract will be it is state of the contract is your storage basically, right? You can use it to store data and extend it if you want with new attributes, and it will also realize into one blob, and it will be one key on the global state. So it is simpler to think about the storage now, right? You don't need to deal with name keys, constants, and like runtime checks. Some of the correctness will be provided by the compiler, right? Because we don't reference storage elements by string, like in name keys. It is just self dot something, and the rest is handled by the macro. And yeah, let's look at the constructor now. So this is also new behavior, right? In 1x, the preferred community way of doing initialization is having separate constructor that is callable only once, right? So for new VM, it is like first class citizen now. The constructor is invoked by the time you install the contract. So you have ability to pass the name of the constructor, and then there will be initialization performed as part of the installation. So if the constructor fails, the contract is not installed as well. So let's say function inc, right? So it has mute self, so the macro knows that it will mutate the state. So it knows that it has to also preserve the modified state. So, but like just forgetting about the macro magic that is dealing with all of that, this is all you need to write like counter, just increment the counter, right? There shouldn't be any much more stuff than this, from like value wrappers or some DSLs or whatever. Just increment the value, right? That's all you need. And then there's some variation of that, like inc by any amount of arguments you can add, and then it's all idiomatic Rust still. And the getter, that's another thing that I want to pursue in the new VM model, where sharing data instead of URefs, because URefs are gone, so sharing data should be based on the entry points and interfaces, right? So if you want to ask a counter, like given counter that is installed under some hash, just like you don't need to get some UREF as before, just call entry point and get the data, right? And there's some improvement, like quality of life improvements, like in 1x, maybe all of you guys know that we have to specify a call export in the WASM that will install the code, but in new VM, there is improvement. You don't need to specify session code. There's improvement that you can give us the WASM and the host will just install it, right? So and it will give you back the contract hash. So that means you don't need to bloat your WASM with extra code just to install the code, right? And the host can deal with that. So that's all you need basically. It's all the code you need to write a counter, right? There's no more, no less. You can compile it, run it on the new VM, and it will be working. And something new at the bottom, summation. Maybe I want to emphasize on that as well. If you remove the goal, one of the goals is that when you remove all the macro annotations, the code should be valid trust. And I think if you look at the test case below, counter works, it's like the test is testing the logic, and this doesn't. You don't need at this point. You don't need to worry about running this code on chain. It's just Rust, right? So we don't need some extra setup. You can just verify your logic this way. And I do believe that it is lowering the barrier to entry to write code. Okay, let's go next slide. Before Q&A, I can show some other extras. Let's say
Yeah,
I'll share my code
absolutely.
briefly
Absolutely.
because
So
there are some other.
I'm gonna stop sharing now. If anyone wants to ask a question, you can use the Q&A, but I also unlocked the chat now so that you can post your messages directly to the chat. Also, if somebody wants to speak up, just let me know in the chat and I will make you a co-host so that you can use your microphone. Okay, giving it back to Michał.
Yeah, so like
Maybe you could make it a little bit bigger, Michał, so
yes,
that everyone can.
I will. So I was talking about idiomatic Rust, right? And leveraging that gives also very interesting, can like open some interesting patterns that will be helpful for development. For instance, here is a CP18 proof of concept contract for new VM, and this is basically the implementation, and we can supply also like reusable code for you, right? Let's say CP18 could be implemented as a trait, and we can supply the trait for you, and you can import that trait and implement a token just by doing uh, this import. Where is it? Yeah, here. So this is all you need, right? You need to import the state struct, and like basically this is inheritance through composition, where we embed another struct into your contract, and then implement CP18 trait, which contains all the implementation. You just need to point it at the state you have, and then that's all. All the entry points will be generated, transfer, allowance, and so on, so on. It will be already in part of your contract, of your WASM. And also you can use those functions in some extra entry points. Like, let's say you want to add some extra entry point that will check some, let's say, my balance. Sure, you can just call the state, get the state, and talk to it and use it, right? So let's say you want some optional features. Let's say some tokens could be mintable. Sure. So we will provide another trait, mintable. If you implement this mintable trait, then you will have mint entry point. And same for burnable. So if you don't do this, then those entry points wouldn't be part of the WASM. And so there's no need for flags, no need for extra checks, like some kind of extra data inside the contract to check if that contract is mintable. We can just, like, it is compiled with the mintable entry points. So it is thinkable, right? We don't need to check extra work or just like load the state. So yeah, I think it's interesting aspect of the new VM SDK where states would be basically if we can ship some, let's say, library with in traits such as CP18, CP78, maybe some kind of ACL checks. Like here, oh, actually, I do have example with this extra traits like trait. What is that ACL? Ownable. Yeah. So this is another example. Like we can ship let's say part of that, let's say client library with reusable code. We can provide trait ownable with some implementation that you can just import and do import ownable for my contract, and then you have all the logic that you can use in the code. So it's very similar. It could be very like we could provide some traits very similar to, let's say, Open Zeppelin when they have a bunch of implementations you can use. So yeah, I think it's great for code reusability and unification of some interfaces, right? And there's other examples like access control state. This is like many people re-implemented it many times probably, but like this is very simple. You need access control. Yeah, so you can just do implement access control for your contract. Then you can use extra code in other entry points, like you can check has role, grant role. Like you can imagine, let's say, upgradable contract that will import access control, and then before performing upgrade on itself, the contract will check, let's say, is this like self.has role caller, and then role, and then yeah, if it has that role, then it can apply from upgrade, right? So I think it's great for reusability and compatibility of different interfaces, different contracts. And yeah, it is very powerful mechanism. We are running out of time, so maybe we can just switch to the I can yeah navigate the code while maybe you guys can ask questions. What blockers are there to factoring out the VM into its own repo? There are the only blocker is the time and the other priorities. I think it will be very good for like I would say cleaner interfaces because let's say in terms of like new VM, let's say storage crate, it is. I'm trying my best to not leak too many, let's say, implementation details like storage and stuff like that. But like separating the code into separate crates, I think it could be great for this, for like making it much more like linear and not dependent upon some implementation details. So then we can technically develop the new VM in parallel to the node, right? So then we will not be bound by the release schedule of the node. So we can basically once new VM will be ready, then we can bump the dependency in the node and then release it altogether. But in the meantime, we can just focus on new VM and not worry about that, right? So I think it would be great. Something, yeah, I need to raise once we are ready. Greetings, dear colleague. Why is our CSPR security better than Supra or other first layer blockchains? Oh, that's tough questions, but what I am doing for security. So we have a bunch of layers and bunch of layers of different testing methods. And in terms of like OPSEC, from OPSEC perspective, I wouldn't go into much details maybe, but let's just say we have pretty good track record of solving 0-day exploits, and we had a bunch of, in the past at least, we had a bunch of engagements with white hat hackers where we cooperated, and we also had some like knowledge transfer, and that led to improvements, and like we could be more reactive rather like more proactive rather than reactive, right? We implemented some additional testing methods, and yeah. In terms of like track record, I think like at least from my perspective, whenever I'm having like say report or some kind of investigation, and I think it's like maybe within for 24 hours usually less than that, we can come up with a fix already. Yeah. So I think it's very open-ended question. Maybe if there's more details, more depth you want to ask, because security, like I think there's a point where like more security doesn't really change, right? There's like diminishing return. So I think we are, as I would say, we are pretty good
I'm going to jump in
with that,
here.
right? Okay.
It's Michael Stoyer. So the question, as you pointed out, Michał, is very open-ended and generic. I mean, I have to say I'm not familiar with the security details of Supra. So if you want a comparison, that's not something that we can do on the fly. And as Michał also pointed out, there are various aspects to security, right? Whether it's the way that you approach the execution engine, which is Michał's area of expertise, which includes security features, such as previously mentioned with groups and access rights and things like that. As well as sort of cryptography related stuff, blockchain related stuff, consensus, etc. So there's a whole gamut of topics in the security buckets that you would need to evaluate and compare. They are obviously always all front of mind for us, but I'm sure the same goes for many other projects, right? So there's no like clear-cut answer to your very broad question, but if you are in our Telegram channels or in other places, I think all of us are always happy to engage around just these types of topics in general, because as many of the engineers working on this project, it's always an interesting topic to sort of discuss around. Let's move on to the next question.
Well, the next one is from Mark, specifically how to disentangle VM from dependency upon node storage crate.
By removing references to the storage crate and replacing it with some interface, and
Wait. Dependency in what sense? So let's just be clear. So this VM or the existing VM or any other VM, if they need global state data, so they're getting data from a TriStore representation that's runtime, right? And then under the hood, there's a to disk for that, which we already have behind trait boundaries. So if you were to want to run the VM on a different model, you should be able to do that. You would just implement the provider traits for your underlying storage, because the actual representation of global state, it doesn't care what the at-rest version of what the at-rest format of the data is per se. It acts against the global state logical definition, which is defined in the traits. So that should already be the case, right?
Yeah. So basically, from like a WASM VM perspective, once you loaded the instance of a WASM, then all the storage interactions is basically key value storage from the perspective of VM. So yeah.
Yeah. So unless there's like some more nuanced version of that question, I believe the answer is it already is.
Yep. So I think there is a question from Patrick that I would say more of a Michael question. I would say it's more like networking and block explorer stuff, or like broadcast, how we broadcast transactions. Do we allow like basically broadcasting anonymous transactions? That's what I understand.
Well, I responded in the chat because it's not very clear the context of this question, because we don't operate SIM cards or infrastructure in countries, and we also don't ensure transaction disappearance. So I think Patrick may be referring to some other project, or there's some context that we're missing.
Comparing transactions is like the opposite of blockchain.
Yeah, we are a completely permissionless, open, and fully discoverable blockchain, right? So there's no disappearing transactions, and there's certainly no SIM cards involved in the gossiping of transactions, because I cannot even begin to imagine what the latency on that would be. No, don't have any other comments on that.
And I don't think we have any other questions. So I guess we can wrap this up. So the next meeting is going to be the last Tuesday of next month. Feel free to share the invite to this meeting with any other who you think would benefit from the meeting. And thank you very much. And thanks, Michał, for presenting. Thanks, Michael and Ed, for inputs. You will be able to watch the entire recording on our YouTube channel.
Thanks, everyone. Have a good day.
Thank you. Bye-bye.
Thank you.